In this video, the ray tracing and hybrid methods as applied in ODEON will be explained. The following concepts will appear: ray tracing method, image source method, secondary source method, vector-based scattering, and particle tracing method. Hybrid methods are applied combining with ray tracing with the other methods. An example of ray tracing is seen here. And here is another example where the rays are shown for the first 3 reflections only. The rays are used to explore the room geometry and to find possible reflection sequences. When a surface is found to create a first-order reflection, the location of the image source is found. For a certain receiver, the line in direction of the image source must go through the surface in order to be a valid reflection. Similarly, for higher-order reflections, here is shown all reflections up to the 3rd order for the chosen receiver position. If we zoom out, we may display the room and corresponding image sources up to the 3rd order in this case. One feature of the image source method is that the early reflections can be shown in a reflectogram, allowing a detailed analysis of the reflections. Concerning the higher order reflection or late reflections, another hybrid method is used, but again starting with the ray tracing. Here is one ray followed through higher order reflections, and the ray can be stopped when the length has exceeded the distance traveled by a sound wave within the expected reverberation time. Now, secondary sources are created at all reflection points. Each source has time delay and frequency dependent strength according to the ray tracing history. Typically, there are several thousand of rays, and each may create maybe 20 to 50 secondary sources or more. For a receiver point, the contributions of delayed energy patches are collected, but only for those secondary sources visible from the receiver. The late reflections and the early reflections are then combined to give the decay curve, which is also the squared impulse response. As the first late reflection may appear before the last early reflection, there is a region where the 2 methods overlap. The hybrid methods can be summarized like this. First, ray tracing is used for exploring the room. Image sources are used for the early reflections, and secondary sources are used for the late reflections. If we now go back to the ray tracing, there is an important detail concerning the reflection of rays. From theory, there are 2 very different principles of reflection: Snell's law for specular reflection and Lambert's law for diffuse reflections. In the latter case, a random number is used to find a reflection direction within the probability function of Lambert's law. In ODEON, the vector-based scattering is used to create a more realistic reflection model. The vectors representing the specular and the diffuse reflection are weighted according to the scattering coefficient of the surface and added to give the direction of the reflected ray. Thus, a small scattering coefficient, say 0.2, means only minor deviations from the direction of a specular reflection. The extreme scattering coefficients, 0 and 1, should not be used. In this example, a single ray is followed through many reflections in a flat rectangular room. A scattering coefficient as low as 0.02 is sufficient to break down the geometrical pattern of reflections as seen without scattering. There is one further application of ray tracing in ODEON, or it might more correctly be named particle tracing. Each ray is assumed to carry a small amount of acoustic energy, and this is reduced after each reflection according to the absorption coefficients of the reflecting surface. Thus, the energy drops as a function of the time, and adding the contributions from all rays together, the global decay curves are found. With this global decay method, the reverberation time representing the average of the entire room volume is found. A point source must be defined, but there is no receiver. This is a quick and quite reliable prediction method for reverberation time, taking the location of absorption material into account. Another result from the ray tracing is the distribution function of the reflection path and the mean free path. The calculation methods explained in this video were developed during the first 9 years of the ODEON project from 1984 to 1995. After that, several refinements and improvements have been added. More about that in another ODEON video.